Hi, folks. Good evening, good afternoon, good noon, good night, whatever. Right, so this is a little lesson on sequences and recurrent relations. Um, I only produced this today, so let's go for it. See, because we're in a COVID situation, if you can hear a washing machine in the background, good. Your hearing is brilliant. Right, so it took me maybe nearly 3 hours to do this today. That's because I was stopping, pausing, asking questions because I'm really annoying like that. So I'm going to go through this a wee bit faster because you can always stop and rewind. Let's see how it goes. We'll speak about sequences here. I know you can read, okay? But just in case you're lying in your bed and listening to this, basically a sequence is just a list of numbers which are created by some kind of rule. And so each number on the list is called a term. And so there's some kind of pattern that connects one term with the next and the one before. So we've got different kinds of sequences. We're going to, there's loads of kinds. So we've got ones that have got a kind of fixed group. Maybe just 0, 1 and 2. Or this one here, 1, 3, 5. And there seems to be a pattern that's taking us all the way up to 99. So this is a fixed group. So the 11 and dot 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 means it's going all the way up to 99 and it stops here. So that's finite. Here, we've got another one, 2, 4, 6, 8, 10, 12. And it's going all the way up to infinity because we don't have an end number here. Right, so that's what looks like it's happening here. Right, okay. Here we've got some notation here for the terms U1, U2, U3, U4, UN, and UN plus 1. I've obviously get fed up of typing. Okay. U1, it means the first term. U2, second term. All the way up to UN, that is the nth term. UN plus 1 is the following term. That's what we're just telling you here. So we're going to go and give you a formula or formulae for the nth term. Because we can have many formulas. So, okay. So this sequence of numbers here, we're going to give you a formula or a method for creating it. But I've just thrown up a little formula here. So UN is equal 5n minus 2. That's just like y equals mx plus c. Or y equals 5x minus 2. It's linear, like a straight line. So in order to create all the values in this sequence, the first number we put in here is 1. So it'll be 5 times 1 take away 2. That would be the first number in the sequence. The next number would be 5 times 2 take away 2. Third number, 5 times 3 take away 2. Fourth number, 5 times 4 take away 2, etc. Just get up 1, 2, 3, 4, 5, 6, 7, 8, 9 until infinity, or whenever the upper cap is. So I'm just going to put this in a table here. So I'm going to have n up there. So in the top row is the values of n, and the bottom I'll be putting in the value for n here. So when n is 1, 5n take away 2, 5 times 3, so it's 5 times 1 take away 2, so that was 5 take away 2 is 3. Next one, I'll go slower here. That's going to be 5 times 2, which is 10 take away 2, which is hopefully 8. Next one is 3. So I'm going to have 5 times 3, which is 15 take away 2, and that's 13. And I've only given you one more box here. So I'm going to put in 4. 5 times 4 is 20. Take away 2 is 18. Yes. And you could just keep going on forever there. That's fine. So that's a formula here to create a sequence by using n values starting at 1. The thing is, you don't have to go through 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. for n. With this formula, you can actually pinpoint a specific value of n. So here, I'm looking for the 30th term, so I will call that U30. That means the 30th term, and the formula was 5n minus 2. I've got rid of n because I'm putting 30 in there. Okay, so 5 times 30, 150, take away 2 is 148. So that there is in position 30 in this sequence of numbers. Right, here we go. Just giving you another formula here. And this time, they're just asking for the first 5 terms. You can do what I did previously and use a table for this, or I'm just going to show you the full-blown version of how I get the values. So, the first 5 terms. So that means I start with n equals 1, so it'll be 1, 2, 3, 4, 5. There's the formula. I bracketed up n because I just want to show you I'm putting in these n values. So I know putting in, putting in. There you go, U1, so that means I've got a 1 going in there, right? That's fine. Next one, U2, means 2 goes in the wee bracket. U3, 3 goes in the bracket. U4, 4 goes in the bracket. U5, 5 goes in the bracket. So just so you go through these here and evaluate. And because I've got the magic button, I can change all those colours. All those numbers in the bracket, I can change the colours of them. But it might appear black to you. It's red to me on my red and white TV. And I'll just go for my black and white TV now. There you go. Let's get the answers. 2 times 1 plus 3, 2 times 2 plus 3, 2 times 3 plus 3, 2 times 4 plus 3, 2 times 5 plus 3. You've sorted it, haven't you? Right, so they would be the first 5 numbers in the sequence. That's all we've asked for here. So if you want to use a wee table, that's fine. Hopefully you notice 5, 7, 9, 11, 13, they're all going up by 2. And the number in front of n, that's responsible for that. Because this is like y equals mx plus c, so that's like the gradient where you go along 1 and up 2. That's why we have an increase. Going from 1 to the next, we are increasing by 2. Right, I've not got my magic pen. That's fine. We've took that on board. Okay. Right. Okay, what's a sequence generating formula? There's various methods you can use here. This is my chosen method. So to generate any term, un, that's the nth term, let's say it's equivalent to d times n plus c. So we need to define what d and c are. But here, I've not defined what d is. N is just the number you're putting in. For this situation, always start with 1. And see, it's just going to be a constant. D, we're going to sort that out soon. Right, let's go and get a formula for this sequence here. It is very, very important to let you know what the first term is here. It's 6. I know you can see it's 6 in the bottom line, 6, 11, 16, 21. But the thing is, you can come up with the same formula for a different sequence. So that's why the first term is very, very important. Right, hopefully you've noticed that going from 6 to 11, 11 to 16, 16 to 21, hopefully you notice there was an increase in 5 there. So that's known as a common difference between one term and another. So they are increasing, so it's positive 5 here. So that's a common difference. Right, so we've got that there. Common difference. First term, u1 equals 6, common difference d equals 5. There's the formula we're going to use. It will define any position in a sequence. So let's go and put our numbers in. Yep, same formula. u1 is 6, first term. Difference, common difference is 5, positive 5. Let's go and put things in. Okay, there you go. Let's start bring down the 6, that's fine. Multiply out the bracket. We should get that there. There's only one thing that's a multiple of n, that's 5n. It'll come down, and then we'll get 6 take away 5, which will give you 1. So probably 5n plus 1 or 1 plus 5n. For me, that's fine. If I'm going too fast, you just rewind. Okay. Again, got another sequence of numbers here. 31, 29, 27, 25, and the start value you want is 31. Right, so let's go and find this. If you want to stop and go and find it yourself, that's fine. Stop the video. Are you back? Okay. Let me go through it. If you're just lying there in your deck chair and don't care, let's go for it. Hopefully you notice the common difference is -2 because we're going down in 2s. This is important. If it was going up in 2s, it would go 31, 33, 35, 37, etc. But it's not, it's going down. This is decreasing. Very important. So the difference is definitely d equals -2. Right, we need the start value as well. it's going to be involved in the formula. U1 is 31. That's our start value, the first value in the sequence. There's a formula there. Okay, we'll get two numbers. So the two numbers we need here are U1, start value, and D, the common difference. We've got them there. Let's put them in. I'll put in additional brackets here because I'm concerned I've got a negative for D. But you should be fine. Let's sort. So that plus minus between 31 and 2, that'll resolve. That plus minus will resolve itself to give us just a wee minus there. Right, and that minus will turn into a negative because it's going to multiply out the contents of the bracket. So then that's the first time we've done that tonight. That's fine. So we'll multiply out the bracket there. Negative 2 times n is negative 2n. Negative 2 times negative 1 is positive 2. The 31 add 2 will interact to get 33, and the negative 2n will just come down there. If you want to write that as negative 2n plus 33, that's fine. Doesn't matter. So that's us come up with a generating formula, okay, that will give you any term in the sequence. So if you want to know about the 10th number in the sequence, just choose 10 in place of n. That'll be 33, take away 2 times 10. 33 take away 20 would be 13. Lucky for some. Okay, we're just continuing with the same scenario here. Give us the list of numbers 5, 9, 13, 17, 21. What do you spot? Starting at 5, that'd be U1. Looks as if we're going up, by the way. Looks as if the numbers are increasing. Are they increasing by a set value here? Right, so U1, yep, and D, that's what we're looking for here. Start number's 5. Just pop that in there right away. So it looks like we're increasing by a certain amount, positive 4. That's what D is, positive 4. I don't need to put a positive next to the 4 there, because your calculator wouldn't give you that. Right. Put the numbers in there, and let's multiply out the bracket. 4 times n and 4 times negative 1. I should have said positive 4. Put them in. The only things that can get grouped are the constants, the 5 and the negative 4. So 5 take away 4 is 1. So the answer could be 1 take away 4n, or 4n add 1. That's what I'm going for. So that's us from that list of numbers here. Here's the formula that will generate any position in the sequence. Right. Hopefully you are okay with that. So I am now going to bin that, get rid of it, and continue. So I'm just going to have a little check that I'm still recording. I am. It's just because I was changing screens there. That's okay. You know me, Techno Tommy, not. Right. Let's continue. We're going to talk about recurrence relations. Something that recurs happens again and again and again. And maybe there's some kind of connection between the again and again and again. Some underlying pattern, just like we had with the sequences that we just looked at there. Right. Sorry, apologies for the handwriting here. That's just what happens when you have these magic pens that I keep referring to that are not that magic. Hopefully you can see that. So this recurrence relationship takes the form, this time it's a wee bit different. Don't worry, we like to change things, to complicate things for you. So this time we've got a connection between un, which is a given term, and well, the answer here is going to be the next term in the sequence. So in order to get an answer, I need to put in UN first, and that ain't the United Nations. Right, okay. So here, like it says, UN plus 1, that's a term after UN. It just depends on UN. We need to feed that in. And here, A and B, they're just numbers, as we're seeing here, constants. So let's start with a nice little example here. UN plus 1 is equal to 5 times UN plus 3. We definitely need to have a start value. The start value is very, very important. We can have different start values when we have a recurrence relation formula. So we are starting with 2. We definitely need that. And they're just asking for the next 3 terms. So what we're going to do here is put in that start value and go for the next 3 terms are going to be U1, U2, and U3. Okay. U1, it depends on U0. That's why it's next to 5. Let's put U0 in there. Its value of 2. 5 times 2, add 3. 5 2s are 10, add 3 is 13. So that's our next value here, U1. Okay, put it up there. Okay, in order to get the one after that would be U2. So we need to take U1 here and put that in next to the 5. Putting that 13 in next to the 5. Right, 5 13, 65 add 3, and hopefully that's 68. So that's us got U2. Okay. It only asks for the next 3, so we'll with our start value of U0 was 2. Then we generated U1, generated U2. Now we need to go and get U3, so we need to take 68 and pop it in there in place of U2. And 568 is 340, add 3 gives you 343. Which I probably said is 7 cubed. Just put that up there. Right, I could have went on further, but that would mean you'd have to do 5 times 343, add 3, and things would just get out of hand. The numbers would just start growing, growing, and growing, getting bigger, bigger, and bigger. So, and just like I'm saying there, it looks, so the terms there, we go first one, you were given the first one, you had to be given that in order to start generating the next numbers, 2, 13, 68, 343, and we just keep going. You can go and check what the next ones are if you want, and keep going until you will see that your calculator will stop giving you answers for this. The numbers will be massive. That's because these are growing exponentially. There's not a constant difference between 2 and 13, between 13 and 68, between 68 and 343. There is not a constant difference. They are growing massively. So that means it would shoot through the roof, and which means there's no upper bound, which we sometimes refer to as a limit for this sequence of numbers. The sequence actually goes on forever. Right, okay. So I'm showing you another one. I'm saying whereas un plus 1 equals 0.4, un plus 3 with u not equal 20 produces some different answers. I'm not going to go through them, putting into the formula individually and showing you them. So 0.4 times 11, what's that? In fact, how did I get 11? Because I put in 20 there. 0.4 times 20 was 4. Sorry, it was 8 plus 3. That's how I got 11. Now, the next one, to get you to put in 11. 0.4 times 11, you can do that. 4.4 plus 3 is 7.4. That's how I get that. Next one, put 7.4 in the formula. Put the 0.4 times 7.4 plus 3. Right, so we're going to start getting more decimal points here. I'll show you later if I can how you can do this in your calculator. With one of my wee videos. It might be a failure, it might not be. Put that number in, 5.96, into the formula and get an answer. Right, okay. Take that number, put it into your formula and get an answer. 5.1536, right. Take that, put it in the formula, get another answer. Right, 5.06144. Again, take that into the formula, get an answer. Take that, put it in the formula, get an answer. Do you notice anything about the answers here? Do you notice anything about the numbers? You started at 11, 7.4, 5.96, 5.384, 5.1536. Do you notice anything about what is happening with the numbers in this sequence? If not, I'm going to show you some more values. There's the 9th one, 10th, 11th. Have we noticed anything here? 12th, 13th. Don't stop there, that's unlucky for some. 14th. I think I'll stop there. I'm running out of ink, electronic ink. What do you think's happening here? Looks as if we're kind of slowing down here. The differences between the numbers is getting less and less and less. Do you think we're heading towards a set number here? I don't know. You could try it with a calculator. So where are we heading towards? Some specific value maybe? We don't know. Those numbers may go on forever. Who knows? Well, I do. So, if there is a specific value, this is referred to as a limit. And so this sequence that we're interested in, un plus 1 equals 0.4 un plus 3. Let's go and see if we can find that without having to go through the process of generating all these numbers. Is there a method? Yes, there is. It's a limit of recurrence relation. That's a formula, okay? So we use the phrase converges here. And this all depends on the values of A and B. They are the important values. So A and B, L is a limit. That's the formula. Where did that come from? Well, just like the quadratic formula came from. Some of you still don't know where that came from. That's fine. Eventually, un plus 1, if there is a limit, will actually equal un. The answers will not change. So that means that you've reached a limit. So that means that the next term will depend on the last term, which will be your limit. And if that's the case, both of them are equal to L. That means we can replace both of them in the formula with L. That's what I've done there. We're trying to find this limit. But there's two occurrences of L here. We need to get L on its own. So we'll get L and we'll get AL on the other side. So we need to bring anything that's got L in it onto the one side. I've taken it over there. So now I need to isolate L. So I need to factorise. Take out the common factor L. So we get L times 1. Take away A times L. Take out L. You've got that there. So that's historical stuff, factorisation, L. So it's L times whatever's in the bracket. I said L times the stuff in the bracket. So times, get rid of the bracket, it'll go across the other side and you'll divide. There you go. So that there is a little formula depending only upon A and B that will give us a limit, if it exists. So I just mentioned if the limit exists. Sometimes it doesn't exist, sometimes it will grow. Because one of the examples I had earlier, we started at 2, we went up to, was it 11? And whatever it was. Then I think we went to, doesn't matter. The last number was 343. I remember that. No, it was 213, 68, 343, right, I think. But the numbers were growing, okay? They would never hit a limit. They would go to infinity. That's not a limit, okay? Infinity is not a number, it's a concept. Right, so can we find a limit? Well, if a limit exists, this depends upon a certain condition. It depends on the value of A. I sometimes call that the multiplier. A has to lie between two values, -1 and +1. -1 and +1 are not included. So along with the formula for L, B over 1 minus A, we can only use that if this condition is satisfied. So this is the first thing you look at. You look at that there before you start using that. Okay. Doesn't matter what A and B is, you can always get an answer. Always. But that answer has no bearing on the problem of, or sorry, the fact that a limit exists. Here, this is the fact that the limit exists if A lies between those two numbers. Right. Just look at two ones here, two questions here. So we're just going to go through them one at a time. And because this is on video, you can rewind this. So apologies if you think I'm going too fast. but I'm not, because I don't want to go over an hour on this, because you want to look at it. In fact, most of you don't look at it anyway. That's fine. So I'm just talking to myself. Okay, let's go and get the value limit if it exists. So we're comparing that there with that general format there. A is a number I'm interested in here. If a limit exists, that's what I'm interested in, A, its value. B will come into it later if a limit exists. So B will come in later. Yep. Okay. Our A value seems to lie between -1 and 1. I'll just put it in there, 0.2. Hopefully you agree that does lie between -1 and 1. That means a limit does exist. So let's go and find it. There's a limit formula. We need A and B, 0.2 and 4. Put them in. 1 take away 0.2 and the bottom 0.8, 4 divided by 0.8, so that's like 40 over 8 is 5. There you go. That's our limit. That's like the question earlier I had, but that's a fluke, because it was a different generating formula we had there. Don't worry. So 5 is the limit here. Do you ever achieve 5? That's something else we need to think about, but not today. Look at the next one. Okay, un plus 1. The next term depends on 1.5 times a present term, take away 2. Right. Okay. We're going to compare it with the general formula, which is a times un plus b. A, we're interested in that. And b will come into it if we do have a limit, if a limit exists. There we go. We're going through the same scenario here. A limit's going to exist if a lies between -1 and 1. But for us, a is 1.5. It does not lie in that zone. Our recurrence relation will diverge because it's not in that zone. It doesn't matter that you can put in values for b over 1 minus 8. That is a condition. And we don't want to go down the road of explaining why a has to lie in that zone. I could, but I won't. That's it. Just check A. Is it in that zone? No, it does not have a limit. Okay. So they like to ask you strange questions about limits. And there's always these questions that come up with unknown, k, and they're saying, so for what values of k does that relationship there have a limit? 5k times un plus 8. So 5k is playing the role of a here. So that's all you're interested in. It's not asking you to calculate a limit. Well, actually, it will come out in terms of k. We're not interested in that. It's the values of k. Well, you know that a here's 5k, b is 8. We don't need that in this problem here. I've just specified it. It's always good to take your A and B values, just in case you need 8. Right, so where does A have to lie between? What zone does it have to lie between to have a limit? And it's indicating that's what they want. So if a limit exists, A must lie between -1 and +1. We're talking about 5k for A. We're not interested in the 5k. We're interested only in values of k. So I need to get rid of 5k and turn it into k. The only way I can do that, don't say take away 4k, because I'm dealing with inequalities here. You can only, well, 5k is on its own, so don't start adding or subtracting things here. We can only multiply or divide. So to turn 5k into k by multiplying or dividing, I divide by 5. So divide all three parts by 5. So -1 divided by 5, 5k divided by 5, and 1 divided by 5 to get that there. So those are the only values of k that will work for that recurrence relation if a limit actually does exist. Okay. Let's go. This is the main part. So just give me a wee bit of time to take that in here. Some kind of factory want to dump waste into a lock. Right, if you were in my class on whatever occasion, I don't agree with this here, but it's all entirely fictitious. Don't take it personal. Okay. But it does actually fit in with this topic here. It's actually a very good question. And it's real, even though I said it's fictitious. It can be real. Okay. Right, 200 kilograms. They want to put that, they want to dump that. That would actually be the original value. So that would be U0 in this problem. Right, next piece of information. So I'm saying here, we get some kind of process that will remove some of the waste, tidal action, and it says it will remove 65%. So if you get this process of either increasing or decreasing the amount, that's actually connected to the value of A. We'll come back to that. Don't just look at 65% and think that's it. It's not. Right. Next part. There's some people, okay, who have genuine concerns that more than a certain amount, 350 kilograms, it'll be harmful to wildlife in the loch. That's another piece of information. That's a target we're looking at here. That's a target number that we'll come back to. So, we get 3 bits of information there. Have we got a question? Yep. Is it safe for the factory to dump the waste? We know they shouldn't dump the waste. That's not the question. Is it safe for them to dump the waste? Right. So let's go back to that part there. 350 kilograms. That's a target. If we're below that target, they're saying, well, it is safe. If it's above that target, it's not safe. Actually, if we're equal to that, technically it is safe. Right, let's go for it. Okay, is it safe? Let's set up the formula here. Let's go and get A and B. So A, that's a process I spoke about. That's a tidal action. So we're taking 65% is involved. Let's go back. We're removing the waste. That's a process. The initial amount, yeah, it's 200, but the 65% will be removed. So how much is left if 65% is being removed? This is for A value. It's going to be 1 take away 65%. That's 1 take away 0.65. That's 0.35. Okay, that's that there. Right, but B value. Well, our B value is, well, after the tide has done its work over a week, what are they going to do? Well, they are going to dump in another 200 kilograms. Oh, that's good. That's your B value. That's your top up value. They're going to add that. Remember, you can rewind this. We'll just put it as 200 there. Don't need the units of measure. Going in until the end of an answer. So we'll get our A and B values here. So let's put them in. Right. Back in the question, we had a target that we were heading towards. Sorry for flipping back and forward, folks, but this is important for you. Target was 350. 350 kilograms. Will we hit that target? Will we exceed that target? Or will we never hit it? There's our formula. What lets us know if we might hit that target, exceed it, or fall below it? Is there a limiting value here? We can check that with A. A is 0.35. It's in the zone of a range. That means there is a limit, so we can go and check for that. We need A and B here. We've got A, it's 0.35. There you go. Bring B back, it's 200. Let's get the formula. B over 1 minus A. Bring the values back, put them in. Okay, let's sort it at the bottom. And 200 divided by that there. Is that a nice number? No, I don't know if I've rounded that, folks. I could have rounded it. I was thinking about their target value of 350, so I thought, okay, I could have went for the nearest unit there. I was just safe. I was going to 2 decimal places for whatever reason. Right, so we've got a target of 350. Is it safe? Right, so now we need to compare our limit. That's what we found. We found the limit. We need to compare our limit with the target value, the accepted amount of waste that they say is fine, which was 350. So our limit is less than 350. So what that means for us is it would seem to be safe, or it would seem that it is safe. Okay, we're just going with their rules, not mine. So it seems that it's safe for them to actually continue poisoning the sea life of the sea loch. Right, go back and look at that again if you're unsure. I think we're going to go on. I think this is going to go on for ages, this one. Right, okay. Next one. These scenarios are all very, very similar. So we're talking about a patient here given 50 milliliter dose of medication. That's a start value. So in these problems, that's the original amount, that's U naught. Next piece of information. Medication will leave the body by various means. So it's saying that 16% of the medication leaves the bloodstream each day. So this is the increasing or decreasing value here. This is related to A because it always multiplies, well, originally U naught. It's related to A, 16%, but it's not necessarily A. It depends on the wording of this here. 16% leaves the bloodstream. I'll let you think about that. Next piece of information. Because we have medication leaving the body, what happens is the patient has to have a top up or a daily booster, we call it here, of 25 millilitres of the same medication. So this is us adding on something extra. If you're adding on something extra in the process that we've started, that's usually the B value. Right. Here, more information. They're giving us a target. So if this level of medication exceeds 150 millilitres, it could be harmful. That's what they're saying to us. So I think we're going to have a couple of questions here, and then we can come back to this. So firstly, we're actually asking you, what is the level of medication in the patient's bloodstream after 3 days? Right, let me just clarify this. It kind of time zero 50 millilitres dose of medication, and at the end of the day, we add another 25 mils. So see, at the end of day 1, that's U1. So we want U1, U2, and U3. So we want 3 further calculations. We're starting at 50. That's U naught. A is related to the 16% that leaves the body. Okay, we're getting this set up. Why is it 0.84? Let's one take away the 16%. We're interested in the amount that's remaining in the body. We get 0.84 remaining in the body. It'll be the multiplier. Okay, and that's your multiplier. Okay, that's what's remaining. That's multiplying any new lot of medication in the body, and the plus B, that is the top up. That's the 25 mils. I've not put in any units here. That's fine for me. I've now got a recurrence relation here. I can start calculating things. And they were asking for the next 3 days. So U1, I have to put in U0. I know that's 50. I can see that at the top right hand corner. Okay, let's put in 50 there and go and calculate it. 67 mils. Right, that's at the end of day 1. That's how much is in the body, in the bloodstream. Let's go and get U2. Put 67 back into the formula again here and come up with an answer. 81.28 milliliters. That's how much medication is in the body at the end of day 2. Okay, so we've only got one further calculation here. That's at the end of the 3rd day, U3. Take 81.28, put it in there, and go and get an answer. 93.28. So we went 50, 67, 81.28, 93.28. So 50 is 67, that's 17. And 67 up to 81 and a bit. What's that? 13, 14.28. So 17, 14.28. That looks as if it's decreasing here. Looks as if it's decreasing. And 81.28 to 93.28 is 12. I've approximated stuff here, folks. I've rounded up. So 17 of a difference. 14.28 of a difference between U1 and U2, and 12 of a difference. So it seems as if it's decreasing. This might be going to a limiting value here. They haven't hit 150, the danger level, the threshold yet. So, is there another question? Yep, there's initial information. Just so you can see it all again. Just emphasising here, it could be harmful if we exceed 150 mils. So here's a question. Is it safe to continue with this? The 150 is the target value. So it looks like we want to know if there's a limiting value. It's just to go back. 50, 67, 81 and a bit, 93 and a bit. It looks as if we're increasing there, but between them they're going down. But will they go down enough to not exceed 150? Well, we need to go and find a limit in order that we know, is our limit above 150 or is our limit below 150? There's our recurrence relation. Have we got a limit? Again, check for the A value. It'll let you know it has to lie between -1 and 1 here. Behave yourself, computer. Has to lie between -1, and it clearly does lie. So that means a limit does exist. Right, let's go and get it. So our limit exists because 0.84 was between -1 and 1. Get our values, put them in, and is it going to give us a nice answer? 25.16. I'm sure it'll give you a nice answer. It gives you a fractional answer in your calculator, folks. Decimalise it. You know how to do that there. So that's our limit, but we've got a target we need to compare it with. That's what we're going to do now. So it's only safe if it does not exceed 150 milliliters. We need to take this number and have a wee think. Well, that's clearly bigger than 150 mil. So, hopefully you would agree it is not safe to continue the course of treatment over a long period of time. But up to a certain period of time, you might be able to continue with it. And we'll look at that in a wee minute. Remember, answer the question they are asking, not the question that's in your head. So, because you have a recurrence relation, and we worked out up to day 3 how much was in the body. That was only up to, was it 90, what was it, 98.28 or whatever it was, 93.28. You can rewind, but it was below 150. So how many days could you actually continue to see if it actually did exceed 150? Because if you can calculate that, it might let you know that, yeah, you could continue this for a certain level of time. Again, this is entirely fictitious and everybody's body is different, so they might not necessarily retain 84% of the drug in their body, in their bloodstream. So, but that's the way things work in statistics. Right. So in order for us to do this, unless you wanted to write out the equation again and again and again, putting in the previous value, we can use the calculator here. So I've made up a wee video for you. A little film. So I'm going to look at that, and I'm going to talk my way through this, because I don't think you can hear the volume. Okay, so that's my laptop in somebody's house, probably mine. So there's a question there. So here's the wee relationship there, and so here, what I'm showing you this calculator because most of you have these Casio calculators. I need to put my original value of 50. So put that in by anyway. That has to be in as an answer. So you could do 2 times 25, 5 times 10. Doesn't matter. Make sure that is at the bottom right here, in as an answer. There's other ways we can do that. So that's definitely, as soon as I've did 50 times 1, I know 50 is in my answer key. So I'm putting in my 0.84 times my answer. So that goes in place of UN times answer. See, I'm hitting that there. Then I put in my plus value is 25, my top up value. Hit equals, it should give me my next value of 67, I think. So I had 50 to start with. So if I hit that, it should give me 67. Because 0.84 times 50 is 32, plus 25 is 67. So hopefully when I hit equals, it will give me 67. So that will be at the end of day 1. Right. See, from now on, all I need to do is hit the equals key and just take a note of the next two. See if it gives you fractions, ignore them. Ignore them. You can decimalize these. Okay, you know what button to press here to decimalize them. And it's actually asked for the number of days. So you don't need to register with either 3, 4, 5, 6, 7. I'm just setting the equals key. 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm heading towards 150. I've hit 16. That's the 16th day. In the 16th day, I'm safe here. hit it again. Oh, I'm over. That's on the 17th day. So if I hit the 17th day, I would have exceeded. So hopefully, if you've got this type of calculator, that's what to do. Make sure your initial number is in your answer. See if you wanted to continue from here and to actually go up and see, oh, can I hit the limit? Just keep on hitting the equals key. You can go and do that. But for this one, it actually takes you ages. Takes you ages. But I'm not going to let you show it because I just keep going on and on and on and on. So I'm just going to take you, and this takes another few minutes. So eventually, there you go. There you go. We got to the end, and you know that was on the 125th day that they reached that limit. But I was in the danger zone. So I'm going to get rid of that. So like I said, that was a calculator job. So hopefully I've taught you something about how to use your calculator, and just once you get your answer in there, just keep hitting equals, equals, and equals. So folks, for this, this was a wee bit tricky, wasn't it? So we never answered that question there, but I've put it down there. So it would exceed 150 mil on the 17th day. That's what they're saying. So we'd probably have to stop on the 16th day. Right. Don't want anybody getting harmed here. Right. I think I'm going to leave it there. So that was quite a long shift there, folks. So for all two of you who actually watch this stuff, then that's good. So, oh geez, oh, that's my longest one so far. Over an hour. Apologies for that, folks. So now I'm going to have to go and get it onto the YouTube channel. Right, bye for now, folks.